Here's where we're going to start today. Okay? Exponents. You don't have to get it out. You can just look. You may want to get your copy out when it's time to work on the work, but let's just look for now. Okay? We've done all of this before, haven't we? Like we made one of these, didn't we? So we have it to refer to if we need to. Are we going to be able to refer to it on the TSI? No, so we have to remember the rules. Okay, so let's very carefully and slowly go over each one of these rules to make sure we remember what the rule is. Okay, if you are multiplying like bases, what do you do with the exponents? You add them. Okay, multiplying like bases, you add the exponents. What if you're dividing like bases? You subtract. You see how those two rules are related? If you're multiplying like bases, you add. If you're dividing like bases, you subtract. Okay? What if you have a power to a power? You multiply by those, right? What if you have something inside of parentheses and you raise that to a power? So everything in the parentheses is being raised to that power. Do you see how these two rules are the same rule? Whether you're multiplying or dividing inside the parentheses, whatever's inside the parentheses is also raised to that power, yes? Okay? And then negative exponents. Are we allowed to have negative exponents? No, remember we talked about that silly story when we talked about negative exponents? We said how this is in the numerator and does it want to be there? No. Where does it want to be? Denominator. When you move it there, now it's so happy. I'm so glad that you remember that. Now I need you to remember it on the test. Okay? If it's in the denominator, is that where it wants to be? No, because look, it's so sad. Where does it want to be? Numerator. And when you move it up there, what is it? So happy. It's positive, right? What part of this problem right here is unhappy? Only the y, right? I know this 2 is negative, but that's one of those grouchy old men. They're just going to be negative no matter what. We can only do something about the negative exponents, right? We move it to the denominator, and when we do, it's happy now. You remember all that? Okay? And last thing to remember about exponents is this right here. Anything to the 0 power is what? Always, right? Anything to the first power is what? Itself, right? But anything to the 0 power is 1. Do you remember all that stuff? Yes. Okay, so I need you to keep it in your head for when you take the TSI. Okay? Some other things I need you to keep in your head. Let's talk about functions. Okay, and I would like you to write this down. Okay, you're more likely to remember something that you write down. Okay? What does the linear parent function look like? So y equals x. And when I graph it, what does it look like? A line, right? But let's talk about this. Isn't that also linear? Oh, absolutely, right? That's a linear function. This is specifically in slope-intercept form, right? And what's this? The slope, and what's this? The y-intercept. Now, can we please talk about a linear word problem? If we're talking about a linear word problem, we don't really say slope anymore. What do we say when we're talking about word problem? We say rate of change, like how fast something is changing. Does that make sense? And what is B if we're talking about a word problem? Where it starts. That's exactly right. Okay? So if I start with $500 and I'm adding $100 per month, what goes where? The 100 is the change, so that's 100x plus 500 because that's what I started with. Does that make sense? Any questions about that? Okay. Quadratic. What is the quadratic parent function? Y equals x squared. Good. What about this? That's standard form of a quadratic, right? If we're talking about a quadratic word problem, what is this? So what is it here? It's my starting point. Guess what it is here? It's just a different letter because it's a different kind of function, right? There's not a slope in quadratic, but C is still my y-intercept. C is where I start. Okay? Exponential. y equals b to the x is the parent function. Okay? This is the one that we've talked about the least in Algebra 2. You talked about it in Algebra 1, but for some of you that's been a while. Okay? So can I remind you about some things? Okay? B has two options. It can either be between 0 and 1, or it can be greater than 1. If B is between 0 and 1, that is called exponential decay. If B is greater than 1, that is called exponential growth. Do you remember that? We talked about that at the beginning of the year, but I'm literally talking about like August, the beginning of the year. Okay? It's been a while. Here's the part word problem-wise you need to know. Okay? Y equals A times B to the X. A is going to be where you start. The first term, where you start. And B is going to be the change. Okay? Now, in a linear function, B was where you, B was where you changed, and M was what you changed, and B is where you started, right? It's kind of backwards here. A is where you start, B is how you change. But here's the thing about parent functions with exponentials, okay? Here's how it might sound if it was a problem. It might say, I have $500 and I want that money to double over 10 years. Okay, what did I start with? 500. So A would be my 500. It's what I start with. And how do I want it to change? I want it to double. So what goes in for B? 2. What's the 10? Because I said it was 10 years. That's what I'm going to put in for X, right? The time is what I'm going to put in for X. Does that make sense? A is what you start with in exponential function. B, the base, is how much it changes. What if I said I wanted to triple? Times 3, right? Or it's not times 3. B would be 3. My base would be 3. Does that make sense? Okay. A lot of times well, I don't want to say anytime. A lot of times when it's talking about an exponential word problem, it's going to be money. So I started with $500 and I want it to double, right? Or it's going to say, it's going to be something like, I started with 6 rabbits and they're going to double their population in a certain amount of time. So that would be 6 and that would be 2. Does that make sense? I started with 5 grams of some sort of what am I trying to say? Radioactive, substance, and it's going to have a half-life of however many years. What's B that time? 1/2, right? Does everybody understand that? Science or money usually is as exponential functions. That's not all, but that's a lot of it. Does that make sense? Okay. Any more questions about exponential? Do you feel a little bit more confident with those now? Okay. What about rational? What's its parent function? Rational looks like a what? A ratio, so it is 1 over x, right? Okay. A lot of these are going to be one person can do the job in 5 years, another one can do the job in 7 years. How can they do it together? Remember us doing that last chapter? And then radical. Y equals what? Square root of x, right? Okay. Does that get some things in your head that maybe haven't been in your head for a bit? Okay. This is the last thing I want to talk about today, consecutive integers. Okay. So if I ask you for 3 consecutive integers, what should we call the first one? X, right? I should call the first one X. What should I call the second one? X plus 1. And what should I call the third one? x plus 2, right? Because this is 1 away from here, and this is 1 away from here, so x plus 1 would be x plus 2, right? Does that make sense? Can somebody give me an example of 3 consecutive integers? 5, 6, and 7. Perfect. Any other examples? 1, 2, 3. How many examples are there of 3 consecutive integers? Like infinite amount, right? There's an infinite number of those examples. Does everybody understand that? Okay. Now we're going to get a little bit, we're going to change it up a little bit. And we're going to talk about 3 consecutive even integers. First of all, before we deal with this, can anybody give me an example of 3 consecutive even integers? 2, 4, 6. Do you see what I mean by 3 consecutive even integers? Okay, if I'm talking about 3 consecutive even integers, what should I call the first one? X. What should I call the second one? X plus 2. And what should I call the third one? X plus 4. Because if this is 2, the next even integer is 2 away from that first one. And the next even integer is 2 away from this one, which would be 4 away from the original one. Does that make sense? Okay. Now, this one will trick you if you let it, but you will not let it. I want to talk about 3 consecutive odd integers. What are we going to call the first one? X. So I'm going to take a timeout here. We're going to go to a quick commercial break. Can somebody give me an example of 3 consecutive odd integers? 1, 3, 5. Somebody else give me another example of 3 consecutive odd integers. 7, 9, 11. Everybody okay with that? Okay. Back to the show. If we called the first one X, what do we call the second one? Do you see why some people have a problem with that? Because they think if it has to be an odd integer, shouldn't I be adding something odd? No, if I start with 1, how far is 3 away from 1? It's 2 away. How far is 5 away from 3? 2 more away, so that would be x plus 2 or x plus 4. Even or odd, it doesn't matter. Even are 2 away from the consecutive integer, even integer with it, but so is odd. Does that make sense? Are you going to let that trick you? You are not. Okay? You will not. Is that a threat? Yes, I'm just teasing. Okay? So here's something that might show up. It might say 3 consecutive integers have a sum of 12. Find the integers. Well, this is 3 consecutive integers, right? So if I know the sum is 12, what should I do with these 3 numbers? Yeah, I should add them because the sum is 12. Well, what's x plus x plus x? 3x. And what's 1 plus 2 plus 3? That equals 12. Is that an equation you can solve? Oh, you better believe it, buddy. Subtracting 3 from both sides gives me 3x equals 9. Dividing both sides by 3 gives me x equals what? X equals 3. Do you have enough information to tell me what all 3 integers are? You do, right? Here's what I don't know. Okay? I don't know if they're going to ask you for the smallest. I don't know if they're going to ask you for the middle, and I don't know if they're going to ask you for the largest of those. So you have to read. You have to read the words. Okay? First of all, be careful if they're asking for 3 consecutive integers. Are they asking for 3 consecutive even integers, or are they asking for 3 consecutive odd integers, or are they asking for 2 consecutive integers, or 4 consecutive even integers? Do you see how any of those words might get erased if you're trying to read too fast? Like erased in your head. Okay? So if you get a consecutive integer question, please slow down and make sure you know what it's asking. Is it asking for consecutive? Is it asking for consecutive even or consecutive odd? Especially if it says one of these two words, I would circle it or underline it or something. So I knew for sure, oh, look, it's telling me even. Does that make sense? And then after you find, if it tells you the sum, then after you find what x is, look back and say, which one is it asking for? Is it asking for, first of all, it could be asking for all three, couldn't it? And if it was asking for all three, what would my answer be? 3, 4, and 5, right? The sum of three consecutive integers is 12. What are the integers? 3, 4, and 5. What if it says, what's the smallest? Well, that's 3. What if it says, what's the largest? 5. You have to remember to go back and add 2 to what you got to find the largest of those three integers. Does that make sense? Do you have any questions about consecutive integer problems or any questions about exponent problems? Are you feeling a little bit more confident about both of these? Exponents just because you got a reminder, and then consecutive, I know we haven't talked about consecutive integers in here, right? Are you feeling a little bit better about these?